Right now, if we consider Wallerian or secondary degeneration, also known as orthograde degeneration, this is a very important topic and is often repeated in exams, so I would suggest you understand this well. Right, so aka orthograde degeneration, and it's basically the set of it is basically referring to the set of degenerative changes that take place in the part of the axon in the Schwann cells and in the macrophages distal to a site of injury on the axon. So for example, we have nerve fiber. This is basically the cell body. I'm representing the dendrites in this manner, right? And the nerve fiber or the axon, both words are used for it, is basically damaged at this point. And there will be set of degenerative events that will take place at 3 different levels. At the level of the soma, it will basically become swollen up. It will also have chromatolysis, which is dissolution of the Nissl granules, which are basically aggregates of polyribosomes. The nucleus will also be pushed to one side, and there will be changes in the cellular organelles. There will also be a set of changes which proximal to the site of injury. This is known as retrograde degeneration because the degeneration is towards the soma, and the degeneration over here is Wallerian or orthograde because it is away from the soma, and this part is known as the distal stump. And this one is the central stump. Right. So what are the set of changes? In the case of the distal stump, which undergoes the type of degeneration referred to as Wallerian, anterograde or secondary, the axon and the myelin sheath become completely degenerated. The changes over here are different. First of all, the exoplasm, which is the cytoplasm, basically it is broken up into small segments, right? The neurofibrils present in this part, they're basically fibers which can be seen in the cytoplasm of the neuronal exoplasm. It basically becomes swollen up, they eventually become tortuous, and then they will disappear. And after some time, the exoplasm or the site where the exoplasm ought to have been present, over there you can just see a small amount of cellular debris. No true exoplasm in the sense. Anyways, so after the injury, degenerative changes they begin quite promptly, right? They actually begin immediately, but they become manifest, meaning they become apparent in 24 hours, and the degenerative changes they are completed by about 3 weeks. So the degenerative changes they begin immediately, but they become apparent within a day of the injury, and they become complete within 3 weeks. The fiber continues to conduct for 3 days and does so for further 2 days, but for the further 2 days the conduction is extremely poor, so it might as well not be present at all, right? So we have talked about the changes in the exoplasm, the fact that it gets broken up into smaller segments, right? And that the neurofibrils they become swollen, then they become tortuous, meaning something that is tortuous is something like that goes like this, lots of bends and such, and then it disappears altogether, and eventually in a couple of days, where there was previously exoplasm, there would just be cellular debris, right? Now additionally, there are changes that happen to the myelin sheath. The myelin sheath also begins to disintegrate, and fat droplets, because myelin sheath is basically fatty material, they begin to appear from the 8th day to the 32nd day, right? And lecithin, that is one of the components of the myelin sheath, becomes complete hydrolysis. The components which include the glycerol, because this is a phospholipid, the fatty acid, the phosphoric acid, and because this is phosphatidylcholine, the base in question is choline. Right, so basically now here the macrophages come in. The number of macrophages, now we have microglial and macroglial cells associated, which are supporting cells of the nervous system, and the microglial cells are basically the macrophages, and they increase in number, right? And they remove these degradation products, and because they will accumulate these products, and because of the high lipid content, these microglial cells or macrophages will now be known as foam cells, and they will be, obviously their tissue cells, they will remain in the region. Lecithin is a lipid, and other degraded products will also be taken up by it, not just these that are the result of complete hydrolysis. And these supporting cells of the nervous system, these macrophages, these microglial cells, are now known as foam cells because of their high content of lipids. Now what about the changes to the Schwann cells? Right, so the endoneurium, it basically remains intact, and the endoneurium is basically the delicate connective tissue sheath that surrounds one neuron. Right, so it's outer to even the myelin sheath, so the endoneurium, it's intact. And the Schwann cells, which basically produced the myelin sheath, they proliferate, meaning their number increases. Right? And the increased number of the Schwann cells, along with the fibrous tissue, leads to a false neuroma. Neuroma is basically a tumor of the nervous system, but false means that there aren't actually any nerve fibers in it. So because the Schwann cells are proliferating, that is generally what happens in any kind of cancerous disorder. There is a massive multiplication. So it's because of the proliferation of the Schwann cells of the damaged nerve fiber that we have the production of a neuroma. But because the nerve fiber itself is damaged and degenerated, the resulting neuroma will be a false neuroma. So I'm hoping this made some amount of sense.